let's understand what is the meaning of flux. The flux, this term is referred to something which is flowing. Okay? Something which is flowing. Say for example, through this pipe, okay, 100 liters of water is flowing per second. Okay, 100 liters of water is flowing per second. And we can say that the flux of water is 100 liters per second. Okay. Say this is a tool bridge. Okay. This is a tool bridge. And from here, let's say on an average, say 100 cars are passing per day. Okay. Okay. Then we can say that the flux of the cars from this toll bridge is 100 cars per day. Okay. Now, so this is a road, okay, a railroad. Now there is some traffic which is passing from here, okay. Now if the flux is high, if the flux is large, then we expect a traffic jam here. Okay? So whenever we say flux, essentially means how much, you see the point number 1, the flux is related to the something which is flowing. Okay? And essentially it tells, the quantity flux tells us, for example in case of water, it tells us how much water is flowing per second. How much water is flowing per second. In case of, say, this toll bridge, that it tells us how many cars are passing per second, okay, from that toll bridge, okay. Now, you know that let's say a simple example, okay. Let's say there is a city and there is only one road which is coming inside the city and there is one road which is leaving from the roads. Okay? And let's say 100 cars are entering in the city per day. Okay? Okay? And let's say same amount of cars are leaving per day. Okay, there is no, it's not possible to park the car in the city, let's say for a minute. Okay? Then if 100 cars are coming per day, 100 has to leave per day. Okay? This is if the parking of the car is not allowed in this part. Okay? Now suppose in the same city, again same rule, okay? You can't park the car here, right? Any car which is coming from outside should not be parked in the city. Okay? Now let's say these 100 cars are coming per day, and let's say there is a factory. Okay, there is a factory. Some company is manufacturing the cars in the city. Okay, let's say this company is manufacturing, let's say 50 cars per day. Also given to you that these cars cannot stay in the city. Okay, so 100 cars are entering per day, 50 cars are produced per day here in this region. So how many cars will be leaving? 150 cars per day must leave. Agree? So you see the flux, which is the outgoing flux, depends upon whether there is a source present within the city or not. Agree or not? The flux of the cars which are going out depends on two things. What is the flux of the cars coming in, as well as it depends on what? If there is a source of car, okay, present in the city or not. Similar kind of thing you will see in the Gauss law also. Okay. Now let me talk about the flux of the electric field. So this is a Gaussian surface. This is some surface. Okay. Now, if there is electric field which is present here, then you can always draw what? Electric lines of force. Agree or not? We can always draw what? Electric lines of force. You know what is electric lines of force? Correct? We also know that the lines of force, the electric lines of force, they are originating from the positive charge and they are terminating on the negative charge. Okay? The electric lines of force originate from positive charge but terminates on the negative charge. Correct? Now consider some surface as shown in the figure. Now some lines of force are coming, entering. Okay? Some lines of force are entering. Same number of lines of force will be leaving provided there is no source or sink. There is no source or sink of lines of force. There is no source of lines of force means there is no positive charge inside the surface. Okay? There is no sink means there is no negative charge inside the surface. You know that the lines of force originate from the positive charge means positive charge is a source, correct? Of electric lines of force. The lines of force terminate on the negative charge essentially means the negative charge is a sink. Okay? Where the lines of force terminate actually. If there is no source or sink, the number of lines of force which are entering will be same as the number of lines of force which will be leaving. Agree? Now look. At this rotation. At this rotation, area vector will be in which direction? This direction. If I define flux as E dot dA, let me define the flux as E dot dA. Okay? Then in that case, here the area vector is in this direction and the electric field is in this direction. Agree? So flux will be what? Negative. Why? Because the angle is 180 degree. E dot dA is E dA cos 180, cos 180 is minus 1. Therefore the flux here, the electric field is in this direction, area vector is in this direction. So here the flux is positive. Okay? So what we can see is this. What we can see from here is this. If the number of lines of force which is entering is same as the number of lines of force which are leaving, then the total flux must be what? 0. Because at the one location there is going to be negative flux. The flux will be negative when the lines of force are entering the surface. But the flux will be positive when the lines of force are leaving the surface. Okay? Then even with the previous example, here the flux of cars can be taken as negative. Okay? Okay? And here it is taken as what? Positive. Okay? The total flux will be 0 provided there is no factory or there is no sink here. There is no source of car, there is no sink. In that case, I can say whatever number of cars are entering, same as leaving. In case there is a source, then we can say that the outgoing flux is more. Outgoing flux is more, means the positive flux is more than the negative flux. Which means the total flux will be positive, provided there is a source within the city. Okay? Here also. If we have a positive charge inside, then the number of lines of force which are entering must be less than the number of lines of force which are leaving. Okay? Okay? The reason is quite simple, because we have the lines, because we have a source of lines of force. Agree? In this case, the flux must be what? Positive. If there is no charge, in that case, the number of lines of force which are entering is same as the number of lines of force which is leaving. Same as the number of lines of force which is leaving. Then we can say that the flux is 0. In case we have a negative charge here, in that case what will happen? The lines of force which are entering is not same as the lines of force which are leaving. In fact, the lines of force which are entering is more than the lines of force which are leaving. In that case, the flux will be what? Negative. This will be what? Negative. So, let's finally conclude. Okay? As far as the flux, the electric flux is concerned, electric flux, we can define electric flux as electric flux linked to a surface as integral E dot dA. Okay? If the surface is closed, I will keep up this sign here. In case surface is not closed, we will say simply E dot dA. Okay? Okay? What does consider the surface? Let's say this is E. Let's say electric field is in this direction. Let's say area vector is also in the same direction. So what is going to be the flux? Linked with the surface, EA cos 0 means E into A. Okay? So what is E therefore? Phi by A. Okay? So how we can define this capital E? We can define capital E as number of lines of force, electric lines of force, passing normally, that means perpendicular, normally to the surface. Number of lines of force passing normally per unit area to the surface. Passing normally per unit area to the surface. Okay? Think for a second why we have defined the flux electric field like this. All I am saying is just one line. Okay? Let me define how many lines of force I will draw. Okay? If let's say the electric field is 1 Newton per meter square, okay, or equally well 1 volt per meter, in that case, we have decided that we will draw only one line of force from a surface whose area is 1 meter square. In case the field is 10 Newton per meter square, then we have decided that we will draw how many lines of force? We will draw in that case 10 lines of force. Okay? So this is the rule that what we are now making. Okay? So number of lines of force drawn in the perpendicular direction per unit area is nothing but the strength of electric field. Okay? Now if I take a cube, okay, let's say 4 lines of, this is a cube whose edge length is 1 meter, means area is 1 meter square. Let's say 4 lines of force are entering. Okay, what does that mean? The field is 4 units, 400 per meter square. Okay, okay. And let's say all these four are leaving, which essentially means what? There is no charge which is inside. Okay? There is no charge which is inside because the number of lines of force which are entering is same as number of lines of force which is leaving. There is no source, no sink. Okay? Now, with this understanding of flux, we will discuss now the gauge law.